Remember that demand is a relationship between the selling price of a product and the quantity people will demand at that price. So think about if a price change is $1. Now, if it's a candy bar that's going up $1, that's a pretty big deal. If it's a computer going up $1, that's not a big deal at all. So just the fact that a price increases or decreases by $1 or so doesn't really tell us the impact on a particular product. What we want to look at there is the percent change in price. So let's look at what that means briefly, and we'll talk about it more later. Percent change in price is equal to the new price minus the old price divided by the old price. And it's the same if it's percent change in revenue. It would be new revenue minus old revenue divided by old revenue, or if it's a percent change in cost. If prices have increased 10%, that's where this kind of thing comes into play. So percent change in price is what elasticity is based on. Now let's look at the definition of elasticity. Okay, let's look at what some of these pieces of the definition mean. Elasticity of demand has a symbol, looks like that. It's pronounced eta, a Greek letter. Eta is a fraction, percent change in demand, Q, divided by percent change in price. Now, eta has no units. We'll have a percent on top, we'll have a percent on the bottom. So eta itself is just a number. And this will also be negative. It's just a number, and it will always be negative. Because remember about demand. If price increases, the demand goes down. If prices are lowered, demand goes up. So that this fraction will always be a number less than 0. It has 3 possibilities. It's always a negative number, but it could be a number so that the absolute value of it is less than 1. So those would be the little fractions. That type of elasticity is called inelastic. Let's say that eta is equal to a negative 0.6. Think about this in terms of our fraction. If elasticity is less than 1 and it's a decimal, then the fraction, let's say there's a 1% change in price. That's an increase of 1% in the price. Then if I'm ending up with a decimal, my numerator has to be smaller in order for it to be not less than 1, but a decimal, where the absolute value is less than 1. So for a 1% change in price, my numerator will have to be smaller if it's an inelastic. And if eta is negative 0.6, I can think about this as negative 0.6 is equal to some percent change in Q divided by my 1% change in price. And when I multiply across, 0.6 would be my percent change in Q. And so I have a negative number, which is what I have to have because it has to be a decreasing fraction, and if the denominator is positive, then that's going to be negative. I said decreasing, negative fraction, decreasing function is demand. Well, after eta less than 1, we have eta greater than 1. Excuse me, absolute value of eta greater than 1. So let's see what that fraction is going to give us. If I have, excuse me, that's called elastic. Again, a 1% change in price. And this time my fraction, my elasticity eta, has to be greater than 1 in absolute value. So I have a larger than 1 change in demand. But again, if price is increasing 1%, demand has to be decreasing. Say that eta is -4. Then if this is -4, that tells me that my demand decreases 4% for each 1% increase in price. That's another way to talk about it. How does demand change based on a 1% change in price? And we consider usually a 1% increase. So we've talked about greater than 1, we've talked about less than 1. Is it possible for eta to equal 1? Absolutely possible. If it's equal to 1 in absolute value, then that means eta itself would equal -1, since we have equality. So that for a 1% change in price, we have to have also a -1% change in demand. So prices go up 1%, demand goes down 1%. This is called unit elastic. And since we're at the place where there's very little change, prices change a little bit, demand changes the same amount, a little bit of up and down, what happens here is you actually get maximum revenue at this point. Whatever price and quantity happened here, it is the place where you have maximum revenue. Top is $15. The elasticity of demand, eta, is -1.5. The new price is $15.75, and we want to know what the effect on demand is for raising the price. So for demand, we know that eta is percent change in demand divided by percent change in price. Well, we have prices, we don't have percent change in price, and we're looking for an effect on demand, so we don't know anything about the top either. So let's see if we can find the percent change in price. We have a formula for percent change in price, or percent change in anything, and it is always the new value minus the old value divided by the old. So our percent change in price will equal the new value, which is the new price, $15.75, minus the old price of $15 divided by $15. So that is 0.75 divided by 15, which gives us 0.05. So if we want a percent change in price, and we have 0.05, That'll give us 5%. So let's take this equation. Elasticity is negative 1.5. Remember, it has no units of any kind. The numerator, percent change in demand, some percent for Q, that is a Q, divided by the percent change in price, which is 5%. In this form, we want to work with percents. So if I multiply across, I have 5% times negative 1.5 is equal to some Q percent. So this gives me a negative 7.5%. So negative 7.5% for the Q, the percent change in demand, tells us that demand will decrease 7.5% for that increase in price. Elasticity of demand for a product can be elastic at some prices and inelastic at other prices. Let's see how that can happen. Suppose our elasticity, eta, is greater than 1. That means demand is elastic. The absolute value is greater than 1. Demand is elastic. So let's think in terms of our fraction meaning for elasticity. Eta has percent change in quantity demanded over percent change in price. Let's say the price changes 1%. And to get a fraction greater than 1, that means the numerator has to be larger than 1%. So if you think about an item, a small change in price, a small increase in price, means a much larger decrease in demand. So if there's a much larger decrease in demand, that tells us that what we have is a luxury item. And as price increases, revenue will decrease. Something where there's a large change in demand makes it a luxury item, so people simply won't continue to buy it. So the revenue decreases. Similarly, if a price was going to decrease, there would be a much larger increase in demand if it was a luxury item. This is for an elastic point at a price. If demand elasticity is less than 1, that is inelastic. So for our fraction, with a 1% increase in price in the denominator, for the fraction to be less than 1, the numerator has to be smaller than 1%. So this means that for a 1% increase in price, there's a less than 1% decrease in demand. And so if it's just a tiny decrease in demand, that makes that a necessity. So the item is necessary. As price increases, there's such a small decrease in demand, that means that the revenue continues to increase. There's not much of a decrease in demand at all, so revenue continues to increase. Okay. Let's look at an example. These are the details from the problem. The price per pair of shoes is $60 when 100 pairs are sold a week. We're told the elasticity is equal to -3, and that there's going to be a price increase to $64.80 per pair. The question is, we need to find how revenue is going to change. And typically, changes are given as percents. Prices have gone up 10%. So for our revenue, we're looking for a percent change in revenue. So let's think about what is a percent change in revenue. Percent change in revenue will be the new revenue minus the old revenue divided by the old revenue. Just like percent change in price is new minus old divided by old. Now, the old revenue is what we have currently. Revenue is price times quantity. P times Q would be 60 times 100. Our old revenue is $6,000. Now, that goes in two spaces. What we have to determine is the new revenue. New revenue, we have a new price. We don't have a new quantity. So our step to begin with is to find the new quantity. Well, what can we use? We're given the elasticity, and remember that elasticity is percent change in quantity divided by percent change in price. So if I could find the percent change in price, I know the elasticity, I can solve for the percent change in quantity, which will give me my new quantity. So we need to find the percent change in price. Well, percent change in price, new minus old divided by old. So let's look over here at percent change in price. My new price is $64.80. My old price was $60. I divide by $60. That gives me 4.80 divided by 60. Can't decrease that. That gives me 0.08. Can't cancel zeros here. That gives me 0.08. Right? That's 8%. So my percent change in price is 8%. So let's fill in for this equation. Elasticity is -3 equal to percent change in Q over 8%. Multiply across, I'll have -24% is my percent change in quantity. Whoa, that's a big drop. My price has increased 8%. The demand has gone down 24%. But that's not a change in quantity, that's a percent change. So I need to figure out how the quantity has changed. Quantity started at 100 pairs. So I have 100 pairs of shoes. I am subtracting 24% of that. That's 0.24 times 100. So my 100 minus 24 gives me 76 pairs of shoes. That is my new quantity. Goes along with my new price of $64.80. Now I can find my new revenue and answer the question that says find the percent change in revenue. So, percent change in revenue. Percent change in revenue equals my new revenue. Price of $64.80 multiplied times 76 minus 60 times 100 is 6,000 over 6,000. When you multiply and subtract and divide, you end up with 0.17, I think 82, something like that. That's the percent change in revenue. So revenue negative. because this is a bigger number here than our 6,000. So revenue decreases 17 to 18%.